Hello friends. Today in this video lecture we will try to understand how to calculate the required amount of memory or the resources for an executor to execute a task successfully in a Spark application. Now basically what is an executor? An executor is nothing but a JVM process inside a machine. So inside a node or inside a machine there could be multiple executors. Okay, and uh, uh, this there and inside a cluster there could be multiple machines. So cluster, then a particular machine, and in that machine there could be multiple executors to process the task. Now let's see an approach. Let's see a way out so that we can understand what would be the required amount of resources to configure an executor inside a machine. We will try with the least approach, least amount of resources that we could provide to construct an executor. So I will start with the note. I'll try to type while speaking. So let's see. We have a cluster. We have a cluster of let's say 10 GB, 10 GB. Oh, sorry, 10 node cluster, 16 cores per node. Each machine has 16 cores and 64 GB of RAM. Okay, so this is our cluster which has got 10 machines, 16. Each machine has 16 cores and 64 GB of RAM. Now we will try to provide the least amount of resources. The least amount of resources that could be given to create a executor inside a machine would be one core and 4 GB of RAM. Okay. Now this could be the least amount of resources that we can provide. Now basically how I got this 4 GB of RAM, simply I thought of distributing the 64 GB of RAM among 16 cores. So 64 divided by 16 is equal to 4 GB. So this is the way I got the least amount of resources that I can provide to create an executor. Now I have got this resource, but the problem with this resource is that I cannot achieve the multi-threading concept, multitasking concept. Okay, big data, as you know, is known for parallel computing or parallel task execution. So when I provide one core could achieve only executing one task at at a moment, not multiple tasks. So disadvantage stage of this approach would be what obvious cannot achieve multi-threading or let's say multitasking. Okay, so we at the particular given moment we can only achieve one task. So this is against the principles of big data. Okay, uh, which promotes what we can say multitasking or parallel computing kind of concept. So this is going to be an disadvantage of this approach, providing the least amount of resources to create an what can say executor. Now let's say another approach. In another approach, we try to provide the maximum amount of resources. So what are the maximum amount of resources we have per machine? Is that we have 16 cores again and 64 GB of RAM. Okay, now I provide all of these resources to create an executor. With the help of such high-end configuration, I can create only one executor per machine. I can create one executor per machine. Of course, when I use all the resources of an machine, so in the out of that resources, I can create only one executor. Now, as I created this one executor, there are certain disadvantages we are going to face over here. Okay, the HDFS throughput is going to suffer. HDFS, first point, HDFS throughput is going to suffer. How? Okay, so the HDFS throughput is going to suffer as we have 16 cores. 16 cores. All these 16 cores will compete among themselves. Okay, all the 16 cores will compete among themselves for the memory as well for the data coming from HDFS. Okay, so they will compete among themselves, and due to this issue, the HDFS will throughput will suffer and it will slow down. It will slow down the it will slow down the data consumption inside executor. Okay, so even this is not a viable option, I would say, to configure an executor inside a machine. Another disadvantage in this approach, in the same approach, would be garbage collection. Okay, GC, because as we have provided high-end machine with 64 GB of RAM to clear the objects, to clear the objects inside the memory take would take large amount of time. Okay, would take large amount of time. So even you see, even this approach of providing high end configuration and using entire resource of a machine to create executor is not a good option, and there are certain disadvantages we are going to face in this approach as well. So instead of using two extreme approaches, we will try to, what we can say, we will try to provide a balanced approach, uh, instead of providing these two extreme approaches to create an what we can say an executor. Okay, so let's take a balanced approach. Okay, balanced approach. Okay, now what would be the balanced approach? Let's say now we have to taken two extreme approaches, providing one core and 4 GB of RAM, the least amount of resources, and another approach providing extreme all the resource, all the memory and the core of a particular machine to create an executor. Now, as we have in balanced approach, as we have 10 node cluster, 16 cores and 64 GB of RAM. Okay, here one core and 1 GB of RAM, we would provide, we would or would be utilized by the OS operations. Okay, operating system, there are certain operating system operations that take place in background, so it will be used by OS operations. uh, okay, now we are left with 15 cores and 63 GB of RAM. Okay, now we have left with 15 cores and 63 GB of RAM, and when I try to distribute this 63 GB among these 15 cores, so I divide 63 by 15. What I get? 21 GB of RAM and 5 cores. Okay, so I get 21 GB of RAM and 5 cores. That means I can create I can create uh, an executor of 5 cores and 21 GB of RAM. Okay, I can create an executor of 5 cores and 21 GB of RAM. So how many executors exactly will be created inside an machine? So the total amount of total amount of executors, total amount of executor that would be created inside machine would be 3 executors. Okay, so with this approach we can see that neither we are creating a single executor, uh, you know uh, using all the resource of a machine, and neither we are creating too many executors. Okay, uh, uh, having configuration of 1 core and 4 GB of RAM. We have taken a balanced approach, not too extreme, not too low, and not too high. Okay, now we have got these 3 executors, each executor having 5 cores and 21 GB of RAM. Now in this uh, concept, uh, for in this 21 GB of RAM on in each executor, 384 MB 384 MB of memory, or 7% of the total memory of the executor, 7% of the total memory of the executor. How much memory we have in a particular in an executor? We have 21 GB of memory, that is RAM, uh, for an executor. So 7% or 8084 MB, whichever is greater, will be taken. Okay, will be taken as off heap memory. Okay, this memory would not be part of your task execution. It is for some optimization purpose that will be taken as an off heap memory. This is not an on heap memory. On heap memory is something where it will be utilized for your task execution, the spark job. Okay, on a particular executor, this 7% or 384 MB, whichever is greater, will be taken as an off-heap memory for some optimization purpose inside your executor. Okay, so uh, when we take 7% of 21 GB of memory, 7%, sorry, 21 GB of memory, it roughly stands around, it roughly stands around 19 or 19.5 GB, 19.5 GB of memory. Okay, so we have when we take 7% of 21 GB of memory in an executor, it roughly stands around 19 or 19.5 GB of memory. So at the end and how much memory, what is the status or what is the configuration of an executor. So it roughly at the end we have 5 cores, okay, and 19.5 or 19 GB of memory, okay. And how much executors can be created, how many executors can be created out of this configuration? We can create 3 executors per machine, okay. So we can create 3 executors per machine. There are total there are total just a moment, there are total 10 machines. So the number of executor will be 10 into 3 into 30 executors. each executor each executor having let's say 19 GB or 19.5 GB of memory. Now out of this 30 executors, one executor one executor will be used by yarn application manager, okay. Now yarn application manager, uh, yarn is an what we can say, resource manager, okay. It provides manages all the resources of the cluster, and and he looks after all the what we can say, creation of configuration of the executors inside machine. So one executor will be provided for the yarn application manager, okay. So we are left out with we are left out with okay, 29 executors. So 29 executors so 29 executors will come into picture inside a cluster which has 10 nodes, 16 cores and 64 GB of RAM. This is the manner in which we can create a balanced approach to configure the memory for an executor that would help us to achieve the parallel computing, provide the right amount of memory and help us to execute a task successfully inside an executor, because the memory is just not required to calculate the executed task. There are some other processes running around this task in background, and even they need the memory and the cores to process that to process the task smoothly inside an executor. So we have to even allocate resources to those background processes as well, so that that would be helpful for running our task on an executor. So in this fashion, and memory configuration or the resource configuration is done for executor. Hopes you have liked the video, you have understood some concepts, and if you have any additional knowledge, you can definitely share in the comment. Thank you very much.